Welcome to another video on applied electronics. So I'll be solving last year's past question. That means end of semester examination of applied electronics 2023-2024 academic year. So I'll start right away. So starting with the first question. A semiconductor has generally, so when you have a semiconductor, it's going to have dash valence electron, meaning 4 valence electrons. Question 2, when a pure semiconductor is heated, so if you heat a semiconductor, we know that the resistance is going to decrease, so meaning the resistance goes down because resistivity reduces when you heat up a semiconductor. Question 3, which of the following is not a semiconductor material? So if you look here, we have germanium, silicon, we have tellurium, and then we have here iron. So iron is not a semiconductor. The battery connection required to forward bias a p-n junction are. So for a p-n junction to bias it forward bias, we have to connect the positive terminal to the p region and negative to the n region. So we have A first. When a trivalent impurity is added to a pure semiconductor, it becomes, so if I'm having trivalence, that means we have a material with 3 valence electrons. So if you are adding it to a semiconductor which is having 4 valence electrons, so there's going to be what? We are going to have holes, right? You have a missing hole, so you create what? A p-type. So we have p-type semiconductor. In the depletion region of a p-n junction, there is shortage of what? Holes and then electrons. Because remember we said the depletion rate become what? Depleted of what? Electrons. So we have C. The leakage current across a p-n junction is due to, here leakage current, here we are talking about reverse current. Reverse current is also called leakage current. And reverse current, as we know, is due to what? Minority carriers. When reverse biased to p-n junction, the width of the depletion layer, so we know that with reverse bias, the depletion is going to what? Increase. So it becomes widened, so it increases. Now, question 9. A diode has, if I have a diode, for example, which is just a p-n junction, see that we have 2 layers. So here we have 2. And then you're going to have 1 junction. So the answer here is what? A. Which of the following can be used to convert AC to DC? So if I want to convert AC to DC, I can use a diode, right? Now, that was question 10. Now question 11. Which of the following rectifier uses only 1 diode? So half wave, for half rectification, we use only 1 diode. Question 12, ripples are low in. Remember, this is a repeated question, so which we did yesterday. We have full wave rectifier. Then question 13, the band gap between conduction and valence band in an insulator is, so the band gap for insulator is going to be high, right? Now question 14, how many types of extreme semiconductors are there? Again, this one too, repeated past question. The answer is 2. We have 2 types of intrinsic semiconductors. We have N-type semiconductor and P-type. We have question 15. As silicon p-n junction in a forward conduction has a voltage drop of 0.7. The voltage drop is going to be the same as the barrier potential of silicon p-n junction, which is 0.7. Now we go to question, right? Okay. So we have question, the p-n junction is a 3-layer, 3-terminal, 1 semiconductor device. Okay. So here the answer is going to be false. So here, I think this is quite different from the other one. From when you look at your past question, if we take it, you realize there are option true or false on it. So here I don't have true and false there, but you can see that we have the answers. So for the question 16, the bipolar junction is a 3-layer, 3-terminal, and 1-junction semiconductor. It's false because the number of junctions for PN is going to be 2 because we have it this way. Let's say you take PNP, for example, we have 2 junctions. Then 16, a bipolar junction can be used to amplify a weak signal. So the answer here is true. In between the cutoff and then the saturation region along the DC load line is a amplifier region of the transistor. So here is true, right? Then we have 19. The output characteristics of a common emitter configuration is a plot of what the output voltage against the output current at a fixed current. So this is the repeated past question. So here the answer is false. When it comes to output characteristic, we are plotting the current against meaning the voltage, not the other way around. So question 20, in PNP transistor action, the base emitter junction is forward biased to the holes in the base and electrons in the emitter region, but it's reverse biased to the electrons in the base. So this is true. In a PNP transistor, the emitter is highly doped, right, with N-type material, and the base is what? Slightly doped. Slightly doped, a P-type material, right? So you can see here when the emitter is highly doped with what N-type is wrong, it should be P-type. So the answer here is false. A PNP bipolar junction has both base and emitter terminals only. No, this is false. For PNP is going to have what? We have the base terminal and the collector. So 22 is 4. In order to obtain a high voltage amplification at the output of the transistor, the low resistance should be high. So this is true. If you want to have a very high amplification, that means you make sure your low resistance is also very high. A transistor cannot only be used as an electronic switch to control devices such as, so this is false. You can use a transistor as a switch to control lamps, motors, and so on. Question 25. The type of bipolar junction transistor is determined by the direction of the flow of current through the emitter. So this is true. The direction of the flow of current determine the type of bipolar junction transistor that we have. So I'll stop here, then we continue with the next questions. So see you in the next video. Bye bye.